textbook likes to give you the picture of the graph and then get you to do something. The exam does this a fair bit too. It makes it a little bit easier because part one of the question is like draw the original graph and then see what happens with the transformation. So we want to sketch y equals g of 0.5x. You notice this 0.5 is inside where the x is. So this is going to affect things horizontally. We are going to multiply the x by, and since 0.5 is a half, the reciprocal would be 2, because x's are liars. We're going to multiply all of our x values by 2. So if I think of key points on here, I'm going to check each of these 4 points. This first point is negative 3, 2. And if I multiplied my x values by 2, it's going to change to negative 6, 2. Second point, negative 1, 5. It's going, if I multiply my x values by 2, it's going to be at negative 2, 5. Here we have 3, 3 is now going to be 6, 3. And for negative 2, if I multiply the x by 2, I get we would call this a horizontal stretch, because we've pulled it away from the x-axis and stretched out the graph. Read the question again. It wants domain and range of both. So my red graph, the domain, the smallest x value is minus 3. It's included. My biggest x value is 4. And my range, my smallest y value is negative 2. My biggest y value is 5. Whoops. And on my black graph, my domain is now negative 6 to 8. And my range is still negative 2 to 5. Does it make sense that our range didn't change? Right? Because we're doing something to the x. So, oh, surprise, y didn't change. Well, if you didn't do anything to the y values, it's not going to change them. But our x values, our domain did change, because what did we do? We multiplied our x values by 2. Notice how your domain, which was negative 3 to 4, is now negative 6 to 8, because you stretched it. And you can circle questions 7, 9, and 10. No, sorry, 4 and 8. I got ahead of myself. You can circle 7, 9, and 10 if you don't uncircle them, because I'm going to give them to you next. But for this one, it's 4 and 8.